Today we're going to talk about sampling distributions. When statisticians take surveys to gather data, it is physically impossible to survey every single person alive. There's between 6 and 7 billion people on the planet, and if you wanted to get a proper survey, you would have to survey every single one of them. But obviously that is impossible and incredibly impractical. So statisticians or pollsters use different types of sampling methods in order to just pick a smaller part of the population to be representative of the whole. And there are 6 different ways that we can sample from a population. The first one and the best one is simple random sample. Meaning, if you have a population, members are chosen from it completely randomly in a way that everyone has the same chance of being selected. When we're talking about statistical significance, simple random sample is the best method. Our next best would be what's called a systematic sample, where members are chosen using a pattern, such as selecting every other. This still is rather random, but not as good as a simple random sample. Next would be a stratified sample, where your population is first divided into groups, and then there are certain members chosen randomly from inside of each group. So the picture to the left here shows that my dots have been divided up into 4 sections, and then from each of the 4 sections, 1 dot is selected at random. Next would be what's called a cluster sample. Cluster sample is similar to a stratified sample in that your population is first divided into groups. But in a cluster sample, after your population is divided into groups, you pick one of those groups to represent your sample. So instead of picking one from each like the stratified sample, you just pick one entire group. Next would be a convenience sample, where members are chosen simply because they're convenient or easily accessible for the surveyor. This would be like if we were in class and I was taking a survey of how many students liked chocolate ice cream. This would be a convenience sample if I only stayed inside my class because those are the people that are easiest for me to survey. It wouldn't be a true sample of our entire student population because it would only represent our individual class, which only represents 11th and 12th graders. It doesn't represent 9th and 10th graders. And then lastly would be a self-selected sample. This one is the least statistically significant because members volunteer to participate. So not every person in your population has an equal chance of being selected, because if you're doing a survey, say on who likes ponies, obviously people who like ponies are more likely to participate than people who don't, because those people are very excited about ponies. So this list really goes from best to worst, because simple random sample is the best because everybody has an equal probability of being selected, and self-selected sample is considered, well, the worst because not everybody has an equal opportunity to participate in your survey. In this example, we're just going to read through them and classify which of the 6 types of samples they are. So the officials of the National Football League, the NFL, want to know how the players feel about some proposed changes to the rules. They decide to ask a sample of about 100 players, classify each sample. So obviously they can't ask every single player in the NFL because there's, I think 82 players on a team and 30-something teams, so there's a lot of people. So they're just picking 100 players to represent their sample. So in the first one, the officials choose the first 100 players to volunteer their opinions. This word volunteer is key because if people are volunteering, then that would make this a self-selected sample. Officials randomly choose 3 players from each of 32 teams in the NFL. So that means that our players were first broken up into teams. So that narrows our choices down to either a stratified sample or a clustered sample, because those are the 2 that have to do with teams or groups. But because they're choosing 3 players from each, that means that this is going to be a stratified sample, not a cluster, because they're picking some from each group. The officials have a computer generate a list of 100 players from a database that includes all players in the NFL. That would be a simple random sample. Since it's randomly generated, that means that every player has the same probability of being selected. High school has 522 freshmen, 495 sophomores, 449 juniors, and 439 seniors enrolled. The student newspaper wants to take a survey of the school, classify each sampling method, which is the most accurate, which is the least. Explain your reasoning. So in method A, randomly select 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors from a complete roster. That means that you're selecting the same number of students from each group. Since our data, or not our data, since our population was first split into group by grade, that is going to make this either a stratified or a cluster sample. And since you're choosing 50 kids from each, that makes this stratified. In method B, we are randomly selecting 200 students from a complete roster. This would make this a simple random sample, because every student in the school has the same probability of being picked no matter what grade they're in. And the last one, choose every 10th student who enters the cafeteria at lunchtime. This would be a systematic sample because we're choosing students using a pattern. Now in terms of which is the most accurate, simple random is the most accurate of these three methods because every student has the same probability of being picked in the school. Our next best in this list would be systematic because it doesn't take into account what grade they're in. Stratified would be the least accurate because it limits your possibilities of being picked no matter which class you're in. So there's the least number of seniors, which means if you're choosing 50 seniors, 50 out of 49 is going to be a higher probability than if you're a freshman, because that would be 50 out of 552. So simple random is the best, stratified is the least. Margin of error of a random sample defines an interval centered on a sample percent in which the population percent is most likely to lie. You hear about margin of error a lot when you're talking about polls and things like that. Usually in political polls, they'll give you the percent and then tell you, there's a margin of error of 3%. So what this is that not every poll is 100% accurate because your population is sampled. So they're giving themselves basically some wiggle room within the poll. So in this picture here, we have 58% of people, let's say 58% of people like Saturday the best day of the week. If the margin of error in this poll is 3%, that means that this poll is accurate within 3%. So it could be 61% of people to 55% of people, because that would be plus or minus 3% from 58. Students at a high school will vote on a proposal to start classes later in the day. According to a survey of a random sample of students, 54% of students agree with the proposal and 46% disagree. The survey's margin of error is plus or minus 5%. Does the survey clearly project the outcome of the voting? So if I have 54% agree plus or minus 5%, that means if I do 54 minus 5%, I would get 49%. And 54 plus 5% would give me 59. So that means between 49 and 59% of students agree with the proposal. Now if we do it for disagree, I have 46% plus or minus 5. 46 plus 5 and 46 minus 5. This would give me 41%, and this would give me 51%. So that means between 41% and 51% of students disagree. Now you'll notice that these percents overlap. If I look at this on a number line, from 41 to 51, disagree, and from 49 to 59, agree, this overlap tells me that this survey is not reliable. If I have a reliable survey, then the margin of error should never overlap. So because I have an overlap here where students can both disagree and agree, that would make this survey not reliable. If they were completely separate, then I would have an example of a reliable survey. Remember, expected value, this was talked about in an earlier video, but expected value is the weighted average of numerical outcomes of an event. So in this example, the expected value of a six-sided number cube with labeled 1 to 6, that would be what value can you expect to roll. So what you do is you just take each value and multiply by its probability and add it up. So I have a 1/6% chance of rolling a 1, a 1/6% chance of rolling a 2, and so on, all the way to 6. So when I multiply those all out and add them up, I get 3.5. So I can get an expected value of rolling a 3.5 on a standard six-sided number dice. It's a little different when our dice aren't standard, though. In this example, I have a net of a cube. Remember that each square of the net represents a different face of the die. I don't have the numbers 1 to 6 here, and the probabilities are a little bit different because there's 1, 1, 2 2s, 2 3s, and 1 5. So if I want to find the expected value here, again, I'm going to multiply each numerical value by its probability. So I have a 1/6% chance of rolling a 1. But now I have a 2/6% chance of rolling a 2 because there's 2 2s, and a 2/6% chance of rolling a 3 because there's 2 3s, and then there's 1 5. So when I multiply those all together and add them up, my expected value for this cube is about 2.6. We can also do expected value with cards. So if I have a stack of cards here, what's the expected value of drawing a card at random? So again, I have 6 cards, so all of my probabilities are going to be out of 6. So I have 1 2, so my probability of drawing a 2 is 1/6. I have 2 3s, 1 4, and 2 5s. So when I multiply those all out and add them up, I get an expected value of about 3.6. And last but not least, we can use the expected value to make decisions or determinations in real-world situations. So Lisa has 2 choices of route when she goes to school. Route A always takes 15 minutes. So no matter what, route A is always 15 minutes. Route B takes 12 minutes unless there's a traffic jam, in which case that route will take 20 minutes. So usually takes her 12 minutes, but sometimes takes her 20. We want to know, is it worth it for her to take that chance of hitting a traffic jam, or should she just stick with her reliable route? So we want to talk about expected value of these events. Now, we'll use EV for short, expected value. So the expected value of route A is just going to be 15 because she has a 100% chance of taking 15 minutes when she takes route A. But now for route B, she has a 15% chance of it taking her 20 minutes, which means she has an 85% chance that it will take her 12 minutes. So most of the time it's going to take her 12 minutes, but sometimes it will take her 20 minutes. So when I calculate that, I get an expected value of about 13.2 minutes. So that means on average, it will take her about 13 minutes to get to work when she takes route B, even if she hits a traffic jam. So this expected value of B being lower tells me that she should take route B and chance the traffic jam because in the long run, she will end up saving time over her commute. Okay, so that is sampling and expected value. I hope you found this video helpful.